All right, now all we have to do is find the y-intercept. So look for this formula right here and just plug in your numbers. So y bar is 1235.08. So just copy the formula here. A equals y bar 1235.08 minus b 24.01 times x bar, which is 43.03. And whatever the b is, that's just the result from the previous calculation. So let's do this here. I'm not sure if the computer's calculator has order of operations built in, so I'm just going to go ahead and, just to be safe, multiply 24.01 times 43.03. Let's do that first. 24.01 times 43.03 is 1,033.15. Okay, and then subtract that from 1235.08. Okay, back to the calculator. One last time. 1235.08 minus 1,033.15 equals 201. Oops, 201.93. Okay, so final answer. Now we have the equation of our line. Need a little more space here. The equation of our line is y hat equals a, back to our, here we go, a plus bx. And so we already figured out a and b. So I'm going to have here 201.93 plus b, which is 24.01, times x. And there is the answer. That is the least squares regression line right there. So that's part B. Find the least squares regression line for predicting metabolic rate from body mass. Add this line to your scatter plot. So now we have to graph this. So you can just make a rough sketch. You don't have to be terribly precise here, but the y-intercept is 201.93. For graphing purposes, let's just call that 200. So up to our scatter plot. So 200, well, 200 is not here on this y-axis here. So I can't really make my line go all the way down to 200. I'd have to expand my graph. And so I will just use the slope here. The slope is 24. So that means every time mass goes up by 1, the rate goes up by 24. So the scaling isn't very very helpful here for determining exactly where 24 is. But if you just were to draw a line, well, let's do this instead. Instead of the slope being 24 to 1, let's times that by 5. And that gives us 5. 24 times 5 is 120. Okay, that's a more useful slope as far as graphing goes. So every time x goes up by 5 kilograms, y will go up by 120 calories burned per 24 hours. And so then I have a little bit better of a sense of the slope here. So from, say, from 35 to 40, we would go up about 120 points from about like 900 to about 1,020 or so. So you can just kind of estimate the line, the slope, kind of like this, and you can see that this line does go through those points. All right, so that's it for part B. Now, explain in words what the slope of the regression line tells us. All right, so for part C, what does the slope tell us? Well, slope is always rise over run. It means for every unit of x, y goes up by whatever the slope is. And so in this case, x is the weight. So in other words, for part C here, if the mass increases by 1 kilogram, then the rate, the metabolic rate, but I'll just say rate, increases by about 24 calories per day. Think of slope as y per x. It's always a unit of y per unit of x change. Okay, last part is part D. Okay, part D. Let's take a look at what part D is asking. It says, another woman has a lean body mass of 45 kilograms. What is her predicted metabolic rate? And this is where these least squares regression lines become really useful. So we have data here from 12 women. These are the actual masses and the actual rates as they were measured. But another woman walks into the room, and her metabolic rate is 45. Excuse me. Her mass is 45. So what can we predict would be her metabolic rate? So if you look on the graph here, you can kind of look up here, and you can kind of tell that it's going to be probably like in the 1300 range, maybe 1200, 1400, something like that. But we can do better because we actually have a formula now. And so here's our formula right here. So just x equals 45 kilograms, and just plug it into right in here. So I'm going to have y hat, which is the predicted metabolic rate for this person, is 201.93 plus 24.01 times x, which is now 45. And just do that computation there. So I'll use my calculator here. I'll do 45 times 24.01 is 1,080. So I've got 201.93 plus 1,080.45. Okay, add those two together. Back to the calculator. So this 1,080.45 is sitting on my calculator right now, so just press plus, and then 201.93 equals, okay, 1282.38. And that would be calories per day. And that's our best prediction on what this woman's metabolic rate would be. And back on the graph, we could see visually around kilograms, 45. We would predict around 1,300 rate, and the calculated rate is pretty close to 1,300. So the graph matches up with what this is. Now, keep in mind, this is only a prediction. The actual metabolic rate of this person, we're not going to know unless we actually take the measurement. But we can be fairly sure that her metabolic rate will be close to this number right here. All right, we're done with the question. I want to make a couple miscellaneous comments. First of all, the equation y hat equals 201.93 plus 24.01x. If you don't want to use x's and y's, you can use any variables you want. And often it's common to use actual words instead of just letters. So instead of y hat, you can say y was the rate. So you could say something like this. You could say the predicted rate is equal to 201.93 plus 24.01 times, and then instead of x, you can actually say what x represents, which is mass, or I guess more accurately, it's the lean body mass. But I'll just say mass here. So then just say mass. Put that in parentheses so we know that's multiplication. And that's a perfectly good formula to use as well. And then one more comment about rounding. Notice there's a lot of rounding going on in this problem. We had, first of all, this number, the 0.876, that was most likely rounded off. We also have the mean, the standard deviation. These numbers are all rounded off. There's a small problem with rounding, and that is when you take rounded off numbers, and then I take rounded off numbers and I do more calculations with them, I get a slightly less accurate number. And then I take that number, which is already possibly not terribly accurate because of the rounding, and then I take that and do another calculation with it later on. There is the potential that your final answer might be a little bit off from what a more accurate answer would have been if I had not rounded off anything. So it's just something to keep in mind. I'm not going to be terribly picky about that, especially on a test when you're in a hurry. It's okay to round off like I did. But if you're doing this for real research or something, I would recommend not round off. Just use a computer like Excel to keep all the numbers, all the digits in there, and then you'll have a more accurate answer. And that is it.